Hello, everyone. My name is Rodrigo, and Juliana Venter and I made this paper where the title is Analysis of the Torque Behavior versus Clamp Force with a different surface treatment in M8 screw. The objective about this paper is analyze the clamp force in a different type of screw joint surface treatment. The stimulus of the study is the most used torquemeter and not runner to access the torque during the assembly. And it's almost impossible to control and dimensional all torques in a product. Design product can't dimension all the torques, and the manufacturing can't assure all the torques. Then about this, for the other assemblies, we are using the generic torques dimensioned to screw thread diameter and the screw class. And the most important during the assembly process is the bolt preload. Then when you use the torquemeter and not run to apply the preload in a bolt or in a screw, then we need to learn and use a formula that we can see in the next slide. Then the principle used for the study is two. The first one is the screw preload is equal to clamp force just after torque. If we don't use or don't have any external loads in this assembly. And the second one is the equation of the relationship between torque and preload screw, when the main variable in this equation is a torque coefficient, the K, the factor K. Then the factor influencing the K factor, we had almost 40 factors, but the main factors that influence in the K factor or the torque coefficient is the hardness, the ruggedness, the screw or not lubrication, thread dimensional tolerance, and the surface treatment of the part. After we did the test, we use equipment to collect the surface hardness for each samples. And for collecting the ruggedness, we use the ruggedness to collect the ruggedness in an area where the head of the screw pass in the samples. About the experiment, the materials and method that we use the hexagonal screw with flange, M8 with a length 35, and the class is 8.20. The material we use flat, and the surface treatment that we use are electric zinc, hard chrome, nickel, and we use some samples untreated for compare the results with the other treatments. The torque went that we use, the range is from 5 Newton meters to 555 for all the samples. Then we initialize with 5 and we increasing 5 Newton meters for until the end. And each point that we apply the torque, we collecting the clamp force. In this picture, we can see the sample about it. We can make the collecting data. Then we apply the torque in a head screw, and we collecting the clamp force using this preload. Then this picture show all the equipments that we use. Then we use a blunt clamp to fix all the parts. We use the torquemeter with a range to 5 to 6 Nm, and we use a 8 BM brand load cell with a capacity to 40 kilonewton. And for each surface treatment, we use 5 pairs of pieces for each surface treatment, and each surface treatment we use a new screw and new nut. For the hardness data, we can see that the hard chrome that had the highest value, and nickel untreated, there's the same hardness, and zinc there a lower value if you compare all the surface treatments. The highest average, it's a hard chrome with 185, and the lowest zinc with 157. About the hardness, we can see that we compare the RZ, all the RZ before it's higher than the after. Then when apply the torque in a parts, all the hardness it's lower. And the most information about our paper, it's this graph, and we can see, and we can compare all the relationship about torque and force clamp about using the treatment surface treatment. Then if we see the hard chrome, it's the blue line. The nickel, it's the orange, zinc, it's yellow, and untreated, it's gray. About our conclusion, the surface treatment of the base of the base parts in a bolt joint has a great influence about the torque versus clamp force. If you can see the graphs, there's a singular line for each surface treatment, and each line, it's a difference between the surface treatment. If we compare the untreated surface with a chrome surface, I back for the slide, and if we compare hard chrome with untreated in 24 Nm, we can see that in a hard chrome we can achieve 16 kilonewton, and in the same line 24 Nm, in untreated samples the value is 30, approximately 30. Then this value is double or almost double if compare the hard chrome with untreated. Then this is important value and the difference between the surface treatment. And it is not possible to arrive at a strong correlation between the ruggedness, hardness, and clamp force variables. That's it. More information, we can see our paper. There are more data. And thanks for watching.